So this is the second video in a series that I'm making on everything that's here on the board, okay? In this part, I'm going to be talking about the lipid bilayer and how things cross that lipid bilayer, okay? So first of all, in order to cross this lipid bilayer, the molecule should be similar to the lipid bilayer, okay? So the ones that are going to most easily cross this lipid bilayer are nonpolar molecules. Why? Because most of the lipid bilayer is nonpolar, okay? Ions that are charged are not going to be able to cross this bilayer very easily at all. They're going to be stopped, okay? They're not going to be able to get through this nonpolar part, the tails, okay? Polar molecules, uncharged polar molecules, they can cross this bilayer, but it's highly dependent on size. The larger the polar molecule, the harder it's going to be for it to cross this molecule. Smaller uncharged polar molecules are going to have an easier time crossing this lipid bilayer. Just for reference, an example of a small uncharged polar molecule would be water, okay? And an example of a large uncharged polar molecule would be a sugar, for example, glucose, okay? A nonpolar molecule could be, for example, benzene or something like that, and an ion might be potassium or sodium or anything that's charged like that. Okay, we can actually measure the permeability of this membrane to a specific solute. There are two different ways, two different definitions, if you will. So this first one is the phenomenological definition, and the second one is the biophysical definition, okay? Well, let's talk about this phenomenological definition first. So what you do is you take two values, okay? You take the difference in the concentration of the solute on either side of the membrane, the difference between them, and you're also going to take the flux. Flux is the net movement of that particular molecule. So at any given time, molecules are moving in both directions. If you are able to observe that the molecule is moving more towards the extracellular space, then you would say that the net flux is in that direction. So you take the net flux and you divide that by the difference in the concentration of the molecule, and that will give you the permeability of the membrane to that specific molecule. The other way to figure out the permeability of a membrane of a molecule is to look at the properties of the molecule and the membrane. Okay, so the two properties that we look at of the molecule are its diffusion coefficient and its partition coefficient. The diffusion coefficient is inversely related to the size of the molecule. Larger molecules are going to have smaller diffusion coefficients. Okay, all that's telling us is that if the molecule is large, it's going to be harder for it to get across. Okay, this partition coefficient measures how lipid or how water soluble the molecule is. If the molecule is more lipid soluble, then that tells us, okay, it's going to be able to get across pretty easily. If the molecule is more water soluble, then the partition coefficient will tell us, no, it's not going to get across very easily. Okay? And then this little d here represents actually something about the membrane. It represents the width of the membrane, how thick it is. Okay? If the membrane is thicker, it's going to be less permeable. If it's thinner, it's going to be more permeable. Okay?